It is humbling to think that either we are alone in the universe with all that number of other potential life-bearing comets, and equally frightening that perhaps there are hundreds of millions of other intelligent civilizations out there.
Whispers in the static, secrets leave a mark. Truth ain't in the daylight, it lives after dark. Ryan's on the trail, pulling threads apart. The Ryan Files after dark, this is where it starts. Angels on the skyline, demons in the mist. Giants in the earth, fists the size of cliffs. Nephilim footprints, history's abyss. Pyramids aligned, but who's making the list? Oh God, sleeping, Yahweh's thunder roars. Secrets in the scriptures, knocking on the doors. From Eden to the stars, the questions never pause. What's the cost of the truth? It's written in scars. Pages burning, lies unravel. Footsteps crunch where the ancients travel. Voices whisper where the echoes babble. Stay curious or let the shadows grab you. The Ryan Files after dark, peeling back the veil, igniting the spark, searching through the cosmos. Truth leaves its mark. Stay curious. This is just the start.
Hello, amazing people. Thanks for joining me this week on the Ryan Files After Dark. Tonight, we're going off-world. Out there beyond our solar system, beyond everything we thought we understood, something is moving fast through the darkness. And it's not from here. For only the third time in recorded history, astronomers have confirmed an interstellar visitor. It's called 3I Atlas, a comet traveling hundreds of thousands of miles per hour, older than our own sun, and carrying secrets from another star system entirely. Is it a message from the cosmos, a natural relic of creation, or something else altogether? To help us navigate this mystery, I'm joined by Terry Moseley, a veteran astronomer and longtime leader of the Irish Astronomical Association, a man who has spent decades helping people truly understand what they're seeing in the night sky. From Sputnik to the James Webb Telescope, from Oumuamua to Borisov to this new traveler called Atlas, we're about to explore what these objects tell us about our galaxy, our origins, and our place in the universe. Buckle in, because this one reminds us of how small we are and how infinite the heavens really are. This is the Ryan Files After Dark. Let's dive in. Ladies and gentlemen, thank you so much for joining me this week on the Ryan Files. I'm very excited. Tonight on the Ryan Files, we're going off-world, literally. My guest is Terry Moseley, veteran astronomer and longtime leader of the Irish Astronomical Association. For decades, he's helped people look up and actually understand what they're seeing, cutting through the noise, the jargon, and the clickbait headlines. Terry, welcome to the Ryan Files. Let's talk about comets, but before we do that, and obviously we're going to get into 3I Atlas, but before we do this, tell us about yourself. A little bit of a background here. You're an astronomer. How'd you get into it? Tell me all about you.
Very good fortune, basically. I've been around since the dawn of the space age, just old enough to remember Sputnik 1, and I actually saw it with my own eyes, which is amazing. I didn't really develop the astronomy until after that, about sort of 10 years after that, although I had a sort of a latent interest there. And I just literally bought a book in a local bookshop with my pocket money, which told me all about the sky, how to make a simple telescope, where to find sources to make a better telescope, and so on. I built a very, very simple one for 5 shillings, basically, back in the day, which is a matter of cents for you guys. And I was able to see the rings of Saturn, the moons of Jupiter, the Andromeda Galaxy, the craters and mountains on the moon, and I just got absolutely hooked and went on then. I was very lucky to be living in Armagh, Northern Ireland, when Patrick Moore, who some of your people may know of, sort of the local equivalent of Carl Sagan maybe, he came over to direct the planetarium there, and I got use of some very powerful telescopes through him. So I've just had an interest in it ever since then. Got really active in the mid-60s, basically. That tells you how long we've been at it. And I am strictly an amateur, but I have been sort of interested in it so long that while I'm not an expert in anything, I have picked up a fair amount of knowledge along the way.
That's awesome. Sputnik, you got this. Is that?
Yeah.
Back in that day, let me ask you, this is just fascinating. I didn't even realize that. what was your thoughts? I mean, because back in the day, like that was a big deal, and
It
people
sure
were
was.
afraid, you know.
Yeah, that was the dawn of the space age and the space race. As you know, the Russians got off to a great start with the first satellite, first dog in space, first man in space, and so on. Then you guys got your act together and said, right, we're going to go ahead on this, show what we can do, and they were first to the moon then with Apollo. But I followed all of that. And also then once the space age developed, it meant that you could put satellites up in space and see things that are not visible from the ground because the Earth's atmosphere blocks the radiation, either the infrared or the microwave or the, gamma rays, X-rays and so on. And we started sending spacecraft to the moon, to Mars, Jupiter, Saturn, all the planets basically. So it's been an absolutely amazing time to be interested in astronomy. And then, of course, the ultimate recently has been the Hubble Space Telescope and now the James Webb Space Telescope. So I can't keep up now, to be honest. I cannot keep up with the stuff that's coming in. We have rovers on the surface of Mars. We have orbiters around Mars. We have spacecraft, as I say, incredibly powerful tools now, and the amount of information that's coming back. And of course, with the availability of the internet now, you don't have to wait for a monthly journal or something. You get the stuff as soon as it comes out. So, but my poor brain is overloaded.
I gotcha. Yeah. Well, you call yourself an amateur, which I don't know where that, like, I guess Olympians are amateurs too. You know what I mean?
Yeah. I do it for the love of it. Basically, I'm not paid.
I understand.
So that's it. But I've been interested in all aspects of astronomy. Started off with the solar system, the planets, and so on, because that was really about all you could do with an amateur telescope. Now with the new techniques and CCD imaging and so on, you can do amazing stuff. But I got interested in Jupiter and Saturn and Mars and the moon, comets, meteors, and so on. And now I do observe not as much as I used to, partly because of light pollution where I live. But I do make a special effort for things like eclipses and meteor showers and comets and so on.
I got you. Well, speaking of comets, we've got one in the news right now. This is a reoccurring theme over the past few years because we've had these interesting guys that are coming from beyond our solar system. I guess you call it intergalactic comets. And obviously we're talking about 3I Atlas. Before we get specifically into that one, just so, anybody out there who doesn't really understand, what are comets? I mean, I guess kind of in the most basic form, explain what comets are so we can get our head wrapped around talking about 3I Atlas later.
The solar system basically consists of the sun, the major planets, a whole lot of minor bodies going around, all orbiting the sun. And of the ones that we're more interested in, the minor bodies are asteroids or minor planets and comets. And they are basically the minor bodies left over from whenever the solar system formed. It's a bit more complicated than that. A comet is often described as a dirty snowball. It's mainly ice, water ice, carbon dioxide ice. Embedded in that are small particles of dust and dirt. And when the comet is away far out from the sun, normally they're in very elliptical, elongated orbits, unlike the planets, which are mainly fairly circular orbits. When they're way far out from the sun, they're barely visible at all. As they come in closer to the sun, they get heated up. The ice starts to not actually melt, but to sublimate, which means it goes directly from ice to vapor. It doesn't go through a liquid phase. And as it sort of boils off, again, boils isn't quite the right word, but imagine that, boils off the surface, it takes these particles of dust and gas with it. And they form, first of all, a coma or a cloud, a giant cloud around the nucleus. The nucleus might be only a few miles in diameter, up to maybe 30, 40 miles in diameter for really big ones. You don't normally see it because of this cloud of gas and dust that boils off, using the term loosely, around it, and that surrounds it. And then as it gets closer to the sun, two things happen. The pressure of the sunlight drives away the gases from the comet, from the head of the comet forming the tail, and also the dust particles get left behind. They're a bit bigger and more solid. They don't get the same pressure of sunlight. They do move to a certain extent. They form a tail. So a comet quite often has two tails, what's called an ion tail or gas tail, and then the dust tail. And that can form quite a beautiful sight. And those little particles that get left behind in the trail of the comet, the orbit of the comet, if the Earth happens to pass through those, then we get a meteor shower. We can talk a bit more about that in a moment because we're in one right at the moment. So a comet is basically a gigantic dirty snowball, small ones maybe half a mile in diameter up to the very biggest ones. We think there's one coming in very, very slowly at the moment, which might be 50, 60, maybe 80 miles in diameter. Well, that is very, very small compared with, say, the Earth. Typical planet, about 8,000 miles in diameter. So a comet can appear very spectacular in the sky, but that is mainly because of the long tail stretching out behind it, which is illuminated by sunlight. And we won't see that with the one we're talking about. There are two others, we'll mention them later. But Comet Atlas is going to be too far away from the sun and too far away from the Earth to be visible to the naked eye. You will need quite a powerful telescope to see it. Now, the interesting thing about it, as you indicated, is that unlike almost all other comets, this one has come from another solar system, another stellar system. 99.99% of all the comets so far are from within our own solar system. They come from a giant reservoir or cloud of such objects way out beyond the furthest one on the planets called the Oort cloud, after the astronomer who first postulated it. Every so often they get disturbed by the gravity of a passing star or maybe one of the outer planets like Neptune, and they fall in towards the sun, and then we can see them. This one has come from somewhere else in our galaxy. We know that because its orbit is not an ellipse. In other words, it's not a closed orbit. It's what's called a hyperbola, an open curve, and is very, very fast, about 200,000 kilometers per hour, 120,000 miles per hour. Much, much faster than any of the comets in our own system. And when we traced it back, people have done their very best to see exactly where it has come from. It's almost impossible to do that because we only have a sort of a limited amount of information about the orbit, but it has come from quite far away in our own galaxy. We can't say how far. If you want, I can go into a bit more detail about that, but the interesting thing is it is literally from another solar system, presumably a star that had planets and comets going around it, and one of them was ejected for whatever reason, a close encounter with a giant planet like Jupiter, and it flung it out of that star system, and it has been traveling for millions, maybe billions, probably billions of years, and has just by chance happened to come close to our solar system. Absolutely amazing. Now, there have been two others before this. This by far the most interesting one. The first object was actually more like a fragment of an asteroid, a long, elongated, rocky thing called Oumuamua, and that raised quite a bit of controversy as well from a gentleman that we'll talk about later. The second one was also a comet, Comet Borisov, but much smaller, not quite so fast, and we didn't really get the chance to find out so much about it as we're finding out about this one. This one is quite unusual, but still a comet, just a comet, to stick my neck out and say that. Well, if you want to go into the details of that at this stage, Professor Avi Loeb from Harvard University, very distinguished institution, has a particular interest, shall we say, in extraterrestrial explanations for things. He thought that Oumuamua was probably an extraterrestrial probe of some sort. He's pretty much out on a limb on that now. Far be it from me as a mere amateur to argue, or not argue, but to disagree with a professor of astronomy at Harvard. But to be honest, 99% of the other astronomers in the business don't agree with him on this. So basically, what he's saying is that for a number of reasons, this object may have an artificial element, maybe not actually created because it's a huge object, a couple of miles in diameter and weighs about 33 billion tons. It would take a very, very advanced civilization to actually make that. But he thinks that it may be used by some other intelligent civilization to send a probe to us. The interesting things about it are, first of all, the speed, very, very fast, much faster than anything else. The orbit, it is in the same plane of the orbits around the sun of the planets, the Earth, Moon, Jupiter, Saturn, Uranus, Neptune, whatever, but it's going in the opposite direction. That, to him, that is significant. To most other people, that's just chance. It's also behaved slightly oddly compared with other comets. It has, for example, emitted gaseous nickel. That's, nickel isn't normally in the form of a gas, but nickel compounds have been emitted. And he says, that's very odd. You don't get that in your average comet. You do, but to much smaller quantities, smaller percentages than in this one. He says you don't get that unless it's an artificial construction of some sort. But there are ways in which it can be explained. Now, we haven't gone out and actually got pieces of nickel from this comet. What we do is we analyze the light from the comet, and the spectrum indicates that there's a nickel hydride basically in being emitted. It can be explained through conventional means. The other thing is, because it's passing directly behind the sun, when it's at the moment, actually, we can't see it because it's more or less directly behind the sun. He says that's a perfect opportunity for this comet to release probes, which will then speed in towards the Earth and presumably not actually attack us, but maybe sort of examine us a bit more closely. To actually do that requires such a huge change in velocity and change in direction that it doesn't seem to make sense. It could be done, but it's probably not the best way to investigate the Earth. Also, he says, because it's passing behind the sun, whoever sent it, don't want us to see it. Well, assuming that we have some degree of intelligence, we can see it quite easily. We can see things that are an awful lot fainter than this comet. And there was no way that it was going to come this close to our solar system, still relatively far away from us and from the sun. We're talking about hundreds of millions of miles away, sorry. There's no way that it was going to come here without us detecting it. So there's a lot of internal contradictions, but it is a fascinating object. It is behaving slightly different to the comets in our own solar system, but that's no great surprise. We have also discovered about 6,000 other planets called exoplanets going around other stars. The very advanced techniques that I mentioned earlier enable us to discover them. And the great majority of them are very, very different, not only from the Earth, but different from the other planets in our solar system. So the fact that this comet is different to our comets shouldn't be any great surprise. There's a huge variety of all sorts of systems out there. The stars are all very different. The planets going around them are all very different. It's no surprise that this comet, which has come from another system, is also a bit different.
There you go. Well, that you just said a lot there.
Yeah.
But I appreciate it. And Avi Loeb, I mean, obviously, like you said, a Harvard scientist. I'm not right. Who am I to diminish anything that he's saying? But I do think that it is fascinating across the board that we have three of these, Borisov, Oumuamua, and 3I Atlas, relatively recently. Is that a pattern, or is that just like maybe we've missed them in the past?
It's probably the latter. The techniques that we have now for discovering faint objects are hundreds of times better than they were even 20 years ago. So there were probably other objects like this, but we just didn't spot them, or we didn't have the orbit accurately enough to determine whether they were from outside our own solar system or not. Oumuamua, for example, was very, very small. Borisov was quite a faint comet. It is slightly unusual that we've had three in the last 10 years, but when people have gone into the technicalities and the orbital characteristics of other star systems, and assuming that they have lots of comets like our system has, they're saying there's actually huge numbers of them will be traveling through interstellar space. Probably not intergalactic space. They can't be accelerated fast enough to actually escape from our galaxy. So we're not going into the third quadrant of the of the galaxy to see things there. But within our own galaxy, objects pass very close, for example, to the giant planet Jupiter. One of them actually passed so close to it that it got captured by Jupiter and went into orbit around it, and then crashed into Jupiter, which was an amazing sight. But it could also equally easily have been flung out of our solar system altogether. And we have discovered other exoplanets that are up to 8 times the mass of Jupiter. So they're very, very massive indeed. Jupiter's about 300 times the mass of the Earth. And these other ones are a lot more massive. So they can very easily fling a comet that comes too close to them out of their system. And then they will simply travel at random through the galaxy. And if there are so many of them, then sooner or later, one of them will come close to our system. And this one came close enough to the sun for us to be able to see it.
Yeah, very interesting. As an amateur, and please forgive my cat.
That's quite okay. Felix?
She loves science.
Yeah. The famous amateur semi-professional called David Levy, who discovered the co-discoverer of the comet that impacted Jupiter, Shoemaker Levy, said cats and comets are together very similar. They have tails and they do exactly what they want. The influence on that was that comets are very hard to predict. We can predict their orbit very easily, but it's hard to predict just how bright they're going to be. So the cat is actually quite appropriate for this one.
Excellent. Well,
yeah. What do you call it?
This is Finn, and she's very, very curious. So
right,
yeah, she'll settle down in a second. So, what I was going to ask is, you mentioned Avi Loeb obviously being a pro. Versus you as an amateur, but I think that it's interesting whenever it comes to controlling the story or the narrative on some of this stuff. There's obviously different communities when it comes to that. One community will believe one thing, and another community will believe another. Is it cantankerous sometimes in that way, or is it just everybody kind of gets their data together and they figure out what they believe?
Well, you're well aware, I'm sure, of conspiracy theories of all sorts. It probably started, and I'm not saying this is a conspiracy theory, but started with UFOs, basically, which go back to the 1950s. Yeah. There are unexplained phenomena in the sky. I have seen things myself that were slightly puzzling, and then I realized what they were. I thought I had actually seen a flight of 7 UFOs in a V formation, flying silently over my head at high speed and suddenly taking a 30-degree turn. But being an amateur astronomer, I had a pair of binoculars with me. I whipped the binoculars out, pointed them up, and it was actually a flight of pigeons flying low over the town, and the light from the town shining up on the white underside of the wings was just enough to illuminate them. But I saw the 7 in a V formation doing that. And if I hadn't had those binoculars there, I would have said I saw UFOs. Now, not everybody has binoculars with them all the time. So to try and get back to your point, there are conspiracy theories about just about everything. I hardly need tell you. You have 9/11, you have UFOs, you have alien abductions, you have the assassination of Kennedy, the Apollo moon landings being faked. You name it, there's the flat Earth. You name it, there's a conspiracy theory about it. Now, I'm not putting Avi Loeb in the same category as that. There is a very, very real argument for saying that there's intelligent life elsewhere in our galaxy. The sheer number of other planets. That's a separate discussion, which I can go into a bit more detail if you want. But if there's intelligent life out there, some of it will almost certainly be a lot more intelligent and more advanced than we are, simply because they've been around for longer. And it is not out of the question that they would send interstellar probes. I mean, Star Trek is fiction, but who knows, in 10,000 years, for us even, it may be a reality. But What we're trying to do then is apply a bit of rationality and science to this particular phenomenon. And there's a thing called Occam's razor, which means basically you cut away all the least likely explanations until you come to the most likely one, and in the absence of any other information, you accept the most likely explanation. And in this case, the most likely explanation is that it's simply a comet. We know for a fact that it's come from outside our solar system. There's no debate about that whatsoever. And if it has come from another solar system, then, as I said, it's quite reasonable that it will be a bit different to the ones that we have in our system. So I'm not saying that Loeb is a victim of a conspiracy theory mentality, but if you go on the internet, you will find loads of other people that have jumped on this, and this is where I have a sort of a bit of beef with him. He has opened up this can of worms, and people are now saying the absolute craziest things about this comet. I read something recently on the web where somebody said that the comet had actually stopped behind the sun and was then going to start firing probes at us. Now, it is physically impossible for the comet to stop. It is traveling at 220,000 miles per hour, and it weighs about 33 billion tons. You don't just stop something like that. I could go on for the whole of the chat about the daft theories there are about this. So people that like conspiracy theories, people that maybe just like hits on their website, simple as that, clickbait, are promoting stuff about this comet that is absolutely ludicrous.
Yeah.
It is a fascinating object. The scientists are turning every available instrument, every available spacecraft towards it to try and find out as much about it as possible. It passed relatively close to Mars at the beginning of this month. I'm going to say relatively close, that's 18 million miles. Still a heck of a distance, but it won't come anywhere near as close as that to Earth. And there were spacecraft in orbit around Mars designed to study Mars, but they turned their instruments around and they had a look at the comet. Now, because it was 18 million miles away and they weren't designed to look at objects that far away, they didn't tell us very much, but they did tell us something. The ExoMars Trace Gas Orbiter has taken an image of it, and nothing unusual has shown up in that image.
Right.
So when it comes out from behind the sun, about the end of, we'll start to see it reasonably easily, sort of about the 20th of November, we'll be getting basically every suitable instrument in the scientific astronomical armory turned at it to find out as much about it as possible. At the moment, we have the observations that were taken before it passed behind the sun, and that alone has given us a lot of fascinating information.
Yeah, absolutely. Well, let's dive into it. You mentioned it, man, and I agree with you. In this world of the Ryan files, I mean, we get into stuff that, some people would call conspiracies, and sometimes there's, there are conspiracies that are just crazy, and but sometimes I think there's conspiracy fact too. Sometimes there's all kinds of whatever power structures that want a certain narrative to be out there. It might not actually be the truth of the matter. That being said, when it comes to this 3i Atlas, that's why everybody they'll come to me, they'll email me, they'll talk to me or whatever, and they'll be like, hey man, you should do something about this. I think it's the end of the world, and I'm like, well, I don't know that it's really that. So if you don't mind, there's just a couple of things that constantly are coming up, and I'd just like to get your opinion on them about 3i Atlas. All right. We're seeing a tail of water, CO2 or, water ice crystals forming the tail further from the sun than normal. And that's something that doesn't normally happen at that far of a distance. What does that mean to you?
It just means that the surface of the comet, perhaps because it has been in interstellar space for so long and will have been bombarded constantly by cosmic rays, for example, that surface is slightly different. because it has come from another system, we don't know, for example, if that system had what we have here, an Oort cloud, which were very, very far out from the sun, between 30 and 80 astronomical units out. An astronomical unit is the average distance of the Earth from the sun. Their system might be slightly different. The composition of the whole system may be different. For example, our sun is what we call a G-type star, fairly average star. Other stars are either a lot bigger and hotter or a lot smaller and fainter. Some of them have very strong magnetic fields. Some of them have much more what we call metals, heavier elements. Some of them have fewer heavier elements. And the whole composition of their system, they may be quite different. Our sun basically formed what we call a protostellar disk, which is a mix of elements produced mainly from the original hydrogen and helium from the Big Bang and other elements that were created by other stars going through their lifetime and blasting off these other elements out into space. Our sun is the only one that we have an actual first-hand example of, a sample of one. Okay, very, very dangerous to extrapolate from a sample of one. We know what the other stars are made of. We have detected all these exoplanets. We can find a certain amount out about them, even though we can't see them directly using the spectroscope. And can't go into the detail of that now. It is not unexpected that a comet from another system would behave differently. The way the water vapor, basically water H2O in vapor form comes off the surface, is determined basically by the amount of radiation reaching the surface. Now, I mentioned that this thing formed a coma. The coma is slightly different to the coma that we see on the average comet in our own system, and it could simply either let more radiation through or let less radiation through. If it lets more radiation through, then the surface is going to sublimate a bit more. It could also be the composition of the surface. As I mentioned, there's a lot of nickel there, much higher ratio of nickel to iron than you normally expect. And Professor Loeb says, oh, well, that's definitely an indication of an alien origin. When you think about that, nickel is not what you build a spacecraft out of. If you want to build a spacecraft, you make it out of the lightest, strongest materials available. Aluminium, titanium, carbon fiber. You don't use iron and nickel. That's for building big, heavy ships to sail the ocean. Even now, sort of modern ships are made of lighter materials. It just does not make sense to have a spacecraft with a high proportion of nickel. It's a useless metal, if you like. It has its uses here on Earth, but not for structural strength and building a spacecraft, which you want to be as light as possible for simply the least amount of energy to propel it. But it's not unexpected that you would get nickel from a different system. So the amount of nickel in the surface then can determine how the water sublimates. And that could be the explanation. We simply don't know yet. We'll have more information whenever we manage to observe it after it passes out from behind the sun.
Speaking of the nickel, and this was interesting. I just had on Dr. Gregory Rogers from NASA. He was a 31 shuttle mission. He was the doctor. And he brought this up. We weren't even talking about it, but he brought it up at the end of the interview. And he said, concerning the nickel, he said, our spacecraft, from Voyager on, the space shuttle and everything else, there are components of nickel in it. A lot of times it's more of the electronic stuff and whatnot. It's not structural. But there's a lot of nickel in it, but there is no iron. Now, his point is that in nature, at least, and you said it really, that was you don't extrapolate from a sample of one. That's brilliant. But he said in nature, you only find nickel. And when you find nickel, it's nickel and iron together. You go through a big process to pull the nickel out.
Yep.
And so that was his big point, is like, this is a high concentration of nickel, and if this is just natural, there should be a lot more iron.
Yep.
That was his point.
Yep. Again, from our sample of one.
Yeah.
geology on the Earth. That is the ratio that we get of nickel to iron on the Earth. That does not necessarily apply to other star systems. I agree, yes, about there being nickel inside any spacecraft. There'd be lots of other metals used as well in part of the electronics. You have palladium and gold gold is often very used because it's a very, very good conductor. Silver, copper. I don't know, I'm not an expert on the inside of spacecraft, but it's not likely to be on the outside. So unless this thing is broken up and exposed all its inner workings to the radiation from the sun, then you would not expect to find iron or nickel. But if there's a concentration of iron or nickel in the actual main composition of the body, then you will get it. Now, that is simply one of the anomalies. There are the anomalies that I mentioned, but you don't have to assume that it's an alien spacecraft to explain that.
Yeah, for sure. The tail behavior is kind of strange
Yeah.
on this one. Some say it even points towards the sun
Yeah.
at some points, which is odd, because usually the tail is pointing in the opposite direction between it and the sun.
Yeah.
Is that magnetism? Is there something else going on?
It's unlikely to be magnetism because while the sun is a magnetic field, it's not really particularly strong out at that distance from the sun. And it's unlikely that there's a significant magnetic field in the comet. This is a bit outside my comfort zone, but I know that the various spacecraft that have visited various comets over the years, from Giotto back in Comet Halley in the 1980s, I don't think they have found a significant magnetic field. Some comets do emit, there's two types of anti-tail. There's one that's purely an optical perspective effect, so we can ignore that. Some do emit an actual anti-tail in that the material is given off more partly in the direction of the sun. This has a tail pointing away from the sun, the average typical comet tail, but it also has a small tail pointing towards the sun. That is possibly a combination of various factors. The sun is obviously shining on the side of the comet that is facing towards it by definition. If a comet is spinning very rapidly, then we saw this actually in some of the amazing images, you actually get a sort of a whirlpool effect, a spiral, like if you imagine a water sprinkler which spins around, and you get a sort of a spiral effect as the water jets come out. Now, the spin axis and spin speed of the nucleus of this comet are unknown, but if it's relatively slow, then the material that is being sublimated by radiation from the sunlight is not being spun around so fast that it ends up on the backside of the comet, and enough of it then can be pointing towards the sun. But it's not even just quite as simple as that. This comet, as I say, is not passing particularly close to the sun. I think it's about 120 million miles at its very closest. A lot of comets go a lot closer than that, and therefore the angle, if you like, that the comet is moving is more aligned towards the sun. This object is actually skimming past the sun at a reasonable distance, so the side facing the sun is not the one that is leading most. It's how can you describe it? Like an aircraft flying past over your head, you only see the front of the aircraft when it's very, very far away from you. When it's passing you overhead, you're seeing sort of the fuselage face on. So it's that sort of, it could be that sort of perspective effect. But as I say, this is a new phenomenon. We don't have a definite answer on that yet.
Yeah. One of the big things, and this is kind of the big thing, especially when you get out there and people are talking conspiracies, is course corrections. People swear it's adjusting its path, not by much, but enough to notice. There's explanations, outgassing and whatnot that could be causing this. But correct me if I'm wrong, but there have been like just minute, for lack of a better term, course changes.
I don't think they have been significant enough. To be honest, I haven't read anything from a reputable source that indicates that there has been any course correction which is not explicable by, as you say, outgassing. I'll admit I haven't seen that.
Okay.
So I just don't know. I'd be extremely surprised if anything amounting to a physical deliberate course correction has been observed. There's very little point in doing a course correction of 0.1%. It isn't going to make any difference to anything. If you want to bring the comet closer to the Earth, you do a course correction of 10%, 20%. That has not happened. So my interpretation of that is if there's been anything there, it has been either simply a recalculation of the orbit, because, every time you observe it, you get a more and more accurate trajectory. So it was only discovered on the 1st of July. So we have only been observing it for roughly 4 months. So the orbit is being recalculated and made more accurate all the time. It's like whenever we think an asteroid like Apophis is going to hit the Earth in 2032 or whatever it is, the initial indication of the orbit, when we only had an approximate idea of its path, indicated that it might possibly hit the Earth. As you get more and more observations, you refine it. You have a larger arc of the orbit to calculate the observations from. They get more and more accurate as you get better instruments on it, as it comes closer, and you simply refine the orbit. So I would assume that is all there has been.
Yeah, that totally makes sense. There are, though, if I'm not mistaken, just in other comments, within our solar system, there are sometimes outgassing can
absolutely
cause the minuscule, but it can cause minuscule.
And absolutely, as you say, and it's simply a result of the outgassing. Every action has an equal and opposite reaction. If this object is actually emitting huge quantities of water, they have sort of said it's typical to the amount of water being fired out from a fire hose, although it's not coming out in a jet. But the total amount is, I forget the exact figure, but a huge amount. That, even though the object weighs 33 billion tons, if you maintain that for a period of days or weeks, that will affect the orbit. Now, it's not coming out in the same direction all the time, and a lot depends on both the spin axis. Is it a vertical spin axis to its orbit, the way roughly most of the planets, with the exception of Uranus, have a spin axis approximately at right angles to the orbit, or is the spin axis actually directed towards the direction of the orbit? That will all affect things like that. I don't think we know definitely what the spin axis is, but it's somewhere between 0 degrees and 90 degrees, put it that way. So that will affect the effect of the outgassing. And it's a very, very small effect. If it was a much smaller comet, then the outgassing could have a more significant object. We don't know the size of this object. The latest figure is somewhere between about 0.5 kilometer and 6 kilometers in size. That's quite a spread. They think it's probably more towards the smaller end of that. The reason is that we have not actually directly imaged the nucleus yet. If it's only 3 kilometers across, which is approximately the middle of that, and it's 200 million kilometers away, not even the James Webb Space Telescope is going to resolve it. It will be less than a single pixel. So we can only guess from the activity that it's producing and how big it is. And as we get better observations, we'll probably be able to get a much better handle on that. Their plan is to try and send some probes to actually intercept it as it goes out of the solar system again, somewhere towards the orbit of Jupiter. Whether they will be able to do that, and if they do, whether they'll be able to get close enough to actually image the nucleus itself, we don't know. But at this stage, we can only guess what size the nucleus is.
Yeah, that totally makes sense, that just as time goes on, we're getting better and better, more and more data, more accurate. And, if it's different than, what we came up with a month ago, well, maybe it's just because we got better data. It's not that there was a course correction. That totally makes sense. And, a lot of people so much of this speculation, that's the thing. People will say, well, it could be being controlled, therefore there has to be something to control it. And then all of a sudden the talk becomes about, well, who's controlling it, whenever we haven't even established that that's what's happening,
Yeah.
So I think there's a lot of confusion about it just because of that. And
Could I just come in with one other comment? It's
Yeah.
relevant.
Yeah.
It's happening at a very bad time in terms of the politics with NASA being shut down at the moment. People are saying NASA is hiding something. Well, NASA actually, unfortunately, is not in a position to release nearly as much information as it normally would. And this has coincided with the comet going behind the sun. So we simply have a huge gap in recent information. The most recent stuff, sorry, there's a bit of a qualification there. We haven't had reasonably recent observations since it passed close to Mars. I think it was the 3rd of October, possibly 4th of October. But it takes a while for people to analyze the results, to check them, to double check them, to cross check them. Nobody wants to publish a paper saying, oh, we discovered gold, for example, on this comet, and then find out that it was a complete and utter haze in their analysis of the spectra. Stuff gets published now on Archive, which is pre-publication. The papers are probably they're being accepted for peer review in the scientific journals. In other words, this looks prima facie like a good analysis of a set of observations. But before we go to print on this, we are going to get it checked by a series of other experts in the field. And it's only at that stage that the thing actually makes print in the Astrophysical Journal or whatever it might be. But a lot of stuff appears on Archive, which is a web which gives you stuff that has been accepted for publication, subject to review. And even that takes a matter of weeks. So we are now getting some papers being published, being made available to the public on Archive that were based on observations several weeks ago. And that's the way the scientific process works. Unless it's something like a supernova that explodes today and we want to see it immediately, then people say, right, there's a supernova in such a galaxy. But for the analysis of anything like that, you're talking normally about a delay of a couple of weeks before something is made official, unless it is so urgent that we say, look, we think we've got something, we need to investigate this. But the analysis, for example, of the spectra of the nickel and so on, and the nickel-iron ratio, that took a matter of weeks before people were happy enough to say, yes, we're sure of that.
Yeah. And just like everything else, man, it's a perfect storm, obviously, with the shutdown and maybe NASA not getting information out and it being behind the sun. It's a perfect storm for, conspiracy theorists. But the truth of the matter is that, things like this things like this happen. And given a vacuum, people tend to make stuff up. It's just, you see it all the time.
Yeah, it's not unique to this. When we sent the probes out to the outer planets, or even to Mars, but particularly to Jupiter and Saturn and their satellites in Uranus and Neptune and Pluto, we were amazed by how different what we were finding was to what we expected to find. And that is within our own solar system. I come back to the point, this is from somewhere else in the galaxy. It is not surprising that it is quite different to anything that we have found from within our own system.
Do we have the ability, Terry, just when you wrap your head around that it's just from somewhere else other than our solar system, do we have the ability, do you believe, long-term research through gathering the data while these, objects come close, get as much information? Do we have the ability maybe to extrapolate or learn more about our entire galaxy and how that might affect travel, possible travel, in the future?
That is why there is so much interest in this. If it was just an average comet, the comet people would be looking at it. Because this is from elsewhere in the galaxy, every astronomer is interested in it. People that are interested in stars, stellar astronomy, are saying, right, can we learn anything about the star system that this thing came from by studying it? What they've done so far is to take the orbit as far as been determined at the moment and trace it backwards. Simple orbital mechanics, you have a few relativistic corrections, but not very much because it's not that close to the sun. But you basically say, right, if we take the orbit and project it backwards, where has it come from? And they have gone out, as far as I recall, to about 100 million light years. Is that right? I think that's right, in our own galaxy. That's fairly close to us. And we can say that the comet passed relatively close to such and such a star and relatively close to such and such another star, but not close enough for those stars to be the origin of the comet. Where has it come from? I need to say a little bit about the Milky Way here. If you look at any of the images that are available on the internet, you can see that most galaxies are spirals with a bulge in the middle. Sometimes we see them face on, sometimes we see them edge on. And if they're edge on, they look like basically two fried eggs laid clapped to back to back, sort of flat disk and a bulge in the middle. If you look at that a bit more closely in our own galaxy, the Milky Way galaxy, there's what's called the thin disk and the thick disk. So that's slightly different if you take the bit of the disk that is narrow and almost exactly confined to the main plane of the galaxy. You get a certain bunch of stars there. In the thicker disk, which is up to about, maybe 15, 20 light years in distance, you get older stars. I'm not going into the detail of that, but older stars with a different mixture of elements. Also, everything in the galaxy, it's a bit like a hobby horse roundabout. Not only do the horses go round and round in a circle, they bob up and down as they go. And that's everything, including our own solar system, the sun, is doing that in our as we orbit around the galaxy. So you have to contend with that as well. The first reaction was that this object, 3I Atlas, has come what we call the thick disk, with the older, much older stars, maybe 8 or 10 billion years old, as opposed to our own sun, which is about 4.5 billion years old. The very latest information that I've seen is that no, it probably comes from the thin disk, the inner disk, which contains stars more like our sun. But there's a lot of other evidence, which I can't really go into, but a lot of other evidence indicates that this is much older than our whole solar system. It's older than the sun, older than the Earth, older than the planets in the comets in our solar system. It's about 4.7, our solar system, about 4.7 billion years old. We think that this object might be as old as 8 billion years old, so almost twice as old as the comets in our solar system. And that would be another reason why it would be quite different. But we're not certain about that.
That's interesting, man. So, wow, just imagine the journey,
Yeah.
This
It could literally have been traveling for 8 billion years.
Wow, that's incredible. You've observed so much in your life, from starting with Sputnik, which I still think is awesome, but so much in the universe. You've had the opportunity to see through telescopes and read about data, all this stuff. When things like Borsov and Oumuamua and obviously 3I Atlas come, what do you feel? I mean, I know we're talking science and feeling doesn't have anything to do with it, but is it more of, just wonder, or is there any kind of warning kind of feeling? Is it, what is it that you feel when it comes to this stuff?
Yeah, for me, it's wonder. It's humbling. We stray a wee bit away from comets here, but basically, you and I and every other person on this earth are made of star stuff, as the late great Carl Sagan said. The elements heavier than hydrogen and helium and a small amount of lithium were all created in stars, or we're finding now some of the very heavy elements are created in things like neutron star collisions, black hole collisions, neutron star, black hole, whatever, the very heavy elements. But absolutely fascinating the way the mixtures of all the elements heavier than iron can be produced. You can go online and search that. But we are literally made from stuff that was made in stars. The iron in your blood, the hemoglobin, was made in the very late stages of the life of a supermassive star. A star like our sun cannot produce enough energy to create elements heavier than iron. This is really going a bit off topic, but as I said earlier, solar systems and stars and the planets in them are created mainly now by a mixture of the hydrogen and helium that was left over from the Big Bang and the materials that were produced by other stars, which evolved far more rapidly than our sun did. The bigger the star, the shorter the lifetime. They end their life by spewing their material out into the universe. That gets mixed up with the hydrogen that there is already there, condenses to form a sun and the planets going around it. So you and I would not be here if it wasn't for generations of other stars that have gone through their lifetime and enriched the cosmos with all the elements heavier than iron. So that in itself is mind-blowing. There's also just the sheer scale and age of the universe. It really is mind-boggling. 13.8 billion years, as far as we know at the moment, the age of the universe. The size of the universe is incomprehensible. Even the observable size of the universe is incomprehensible. The number of stars in the universe is incomprehensible. 100,000 million, 200,000 million in our Milky Way galaxy. The number of galaxies that we know of is even greater than that. We also think that on average, each star has a system of planets going around it. So the number of planets that exist in the universe is even greater than that number of stars. It is humbling to think that either, as Carl Sagan said, I think it was him, very frightening that either we are alone in the universe with all that number of other potential life-bearing comets, and equally frightening that perhaps there are hundreds of millions of other intelligent civilizations out there. The caveat is they are so far away that it's very, very unlikely that we will go to ever visit them, and probably equally unlikely that they're going to come and visit us. Communication by radio, by lasers, whatever is a different matter, but the actual travel distance is just mind-boggling. There is a speed limit in the universe. The speed of light, 186,000 miles per second. We're talking about hundreds of years to get to where it is probably the nearest other inhabitable planet around another star. That's off topic.
Unless we create a Einstein-Rosen bridge.
Yes.
You
know more about science than you're letting on.
Oh, yeah. Well, anyways. Let's see if there's any other things. One little topic, too, that I just wanted to kind of get your opinion on. You're right in the middle of it. You would know this. Astronomy. Okay.
Yeah.
There was a time, no doubt, and you've gone through this, so you can talk about the history of this. Astronomy, just amateur astronomer. There was a time whenever it really mattered big time to the field, because you would have just amateurs out there just scanning the sky. They would pick something up. They would send it up the chain of command, so to speak. And then, the big guys would start taking a look at it. Does that still exist today?
Very little, unfortunately. And unfortunately, from the point of view of the amateurs, in that almost every amateur astronomer would like to discover a comet or a supernova. And there was a time when almost all new comets were being discovered by amateur astronomers or semi-amateur, and quite a few supernovae were being discovered by amateurs as well. Now there are so many automated systems set up with telescopes in the most favored parts of the world for clear skies and good conditions is extremely rare. One of the two comets that is just about visible to amateurs at the moment was actually discovered by an amateur astronomer, but not with his own telescope. He was looking at the images of the SOHO spacecraft, which images the sun. And if a comet goes very, very close to the sun, even a tiny little one, it gets quite bright, and you can see it passing across the images of the solar spacecraft. So Comet Swan was discovered actually by a Ukrainian amateur astronomer looking at the SOHO images. And he's credited with the discover, although it's called Swan because it was discovered by the Swan instrument on the SOHO spacecraft. But one of the most amazing guys I ever met discovered, I think, 7 comets and 5 novae, not supernovae, but smaller novae himself, just by going out with a pair of binoculars and scanning the sky every clear night. A fellow called George Alcock. There's a guy in New Zealand, his name has just gone out of my head at the moment, has discovered again, a significant number of novae and comets and so on, but it is very rare now because almost all comets are discovered now by these specialized systems set up, not specifically necessarily to discover comets, but to discover asteroids which might be on a possible collision course with the Earth, like Atlas. That's the Asteroid Terrestrial Last Impact Alert System. So Comet Atlas was actually discovered by that automated system, and it picks up stuff that you simply won't see in your average telescope. Scanning the whole sky every couple of days, other ones take longer, but they are discovering almost everything now. But there certainly was a time when amateur astronomers not only were doing that, but were contributing actual valuable research. For example, meteor research for a long time was almost exclusively conducted by amateurs because the professionals didn't have time to set out under a clear sky for a whole night just looking for shooting stars. Some of the early observations of Jupiter, for example, were made. I did a lot of that when I was younger. The rotation period of the various regions on Jupiter, simply by observing it with a telescope and timing when features passed into view and passed out of view. But now, while you can still do a certain amount, and there are things like spectacles that you can enjoy, like the aurora, the northern southern lights, noctilucent clouds, eclipses, and so on. You can still get a tremendous amount of enjoyment and satisfaction out of that. And it brings the wonders of the universe home to you if you see something like a really good aurora display. But in terms of scientific contributions, you need to be pretty well equipped with a good telescope and good equipment to do things like hunting for supernovae, detecting asteroids, and so on. Asteroid occultations, I know quite a few people that do things like that, and they're contributing in their own small but very important way to astronomical research. But the average guy going out into the back garden with a pair of binoculars is very, very unlikely to be the discoverer of a new comet, or I'll say, or a girl as well, because quite a few astronomers now are equally good in imaging, for example, astronomical photography. Some fantastic photographs that I know being taken by female amateur astronomers.
It's kind of sad. Listen, I mean, progress is progress, but there's a certain romance to the, to the career that you've had.
Yeah.
Just when there was a time when it was like, I don't know, there's a certain romance to it, just of discovery and whatnot that, I mean, and I get it, progress, we move forward, we get better, telescopes and instruments, and probably makes our planet safer and everything else. But yeah, it's kind of sad to see that epic of time go,
Yeah, there are mind-blowing moments, particularly when you live in a country like I do, when there's a lot of cloud. Yeah. A very famous comet that came along just before Hale-Bopp was one called Hyakutake. And it was getting brighter and people were raving about it, and the airline pilots were saying, we can see this amazing thing just looking out through the cockpit without even switching the lights off. And I was sitting under 2 weeks of perpetual grey cloud, just total overcast. Then one night it cleared, and there was this absolutely amazing comet with a head the size of the full moon and this tail stretching 40 degrees across the sky, more than the diagonal on a good old-fashioned 35mm camera frame. Just mind-blowing. And that just suddenly appeared because I got a clear sky. And I remember thinking, this is just unbelievable. Just unbelievable. It was glowing a bright blue-white And I got some lovely photographs of it just with the old-fashioned camera. But that's something that you never forget. I've seen other comets where they started off so faint that I had to use my big telescope to see them, and you watch them gradually get a bit brighter and brighter and bigger like Hale Bopp. But seeing that for the first time in all its glory was something that just, as you say, the romance of the subject, and that still happens.
Yeah, that's good. I love it. I love it, man. And there's a passion behind what you do that I find it contagious, man. That's great. So in early December, late November, early December this year, 3i Atlas is going to come out from hiding. And obviously,
that's a loaded term.
Yeah. And obviously we know what the predictive path is and whatnot. Okay. And everything should just be fine. What? I mean, and we're getting into speculation here, but what if it isn't?
That would be amazing.
Yeah.
I mean, I get a lot of questions about UFOs, and I say I've seen lots and lots of things in the sky, and I would absolutely love if one of them actually was a UFO, particularly if they land in my back garden and say, hi, using the babelfish, and, and just even detecting by electromagnetic communication, a contact with another civilization. I would love it to happen. I just don't think it has happened yet. I don't think the various things that have been seen in the sky that people think are UFOs are actually alien spacecraft. But yes, to answer your question, it would be absolutely amazing. It would be a paradigm shift in not only sort of science, but of our conception of our place in the universe. It would be proof that there actually are other intelligent civilizations, and maybe not all that far away. Okay, we think this thing has come from very, very far off in the galaxy. If it's an artificial craft, that's probably not the case. It's just sort of been put into an orbit that makes it look like that. And if there is something there that is coming to investigate us, that was created by another advanced intelligent civilization, that would be amazing. It would have profound implications for religion, for example, for philosophy, for your sense of sort of, we think we're the bee's knees, by far the most intelligent and advanced species on the planet. But if somebody else out there in the universe can do that, it puts us very much in our place. So I would love that to be the case. I just think it's extremely unlikely. The other thing is, if they come, are they benign or are they malign? Are they coming, bearing goodies, or are they coming to say, right, what is it in the Hitchhiker's Guide to the Galaxy, or one of the science fiction films anyway, nice planet, we'll take it.
Yeah.
So yeah, our own history here on Earth, when people went and discovered new countries, and the people going there were the more advanced, it didn't always end up well for the original inhabitants of those countries. Yes. And that could be what would happen to us. The other way of looking at that is, if a civilization is so advanced that it can do that, it has learned to get past war as a means of sorting out problems. In other words, if it hasn't blown itself to pieces, then it is possibly going to advance to the point where it can master interstellar travel. And if they're doing that, then like Star Trek, they will come without any evil intentions. But I would love that to be the case. I just don't think it is. Not this time.
Well, we'll see here, I guess, in a few months. But I'm with you, obviously. But boy, you talk about totally changing the glasses through which you see the world,
absolutely,
in the universe. That would change everything. Talk about disclosure, Lord, that would be yeah. Man, this has been fascinating. Do you mind if I ask you one more question?
Sure, go ahead.
I can only ask this to an astronomer.
Right.
I have no idea of the answer either. I have no idea what's going on, but I am completely baffled by the northern pole of Saturn and that hexagonal, whatever cloud structure. What is going on there? What is that?
I honestly don't know. Absolutely honest. It's something to do with a sort of a resonance frequency with the rotation period of Saturn, which is very fast, about 10 hours, 15 minutes. It spins on its axis, possibly the magnetic field. We surmise that the planet has a solid or semi-solid core, whereas all the outer part of it are gaseous. There'll be probably a transition region in between where it's sort of maybe something like slush. We just don't know. I'm fascinated by it too. You're not implying that that is artificial simply because it is a hexagonal shape. For start, it's not a perfect hexagon. It's pretty close. It's just some sort of pattern. You can get patterns in our own atmosphere where you get alternating clockwise and anti-clockwise vortices downwind of a mountain. You may have seen some of the photographs of the clouds that they form. The clouds form over the top of the mountain. The wind blows them downstream of that, and they twirl alternately clockwise and anti-clockwise. And that looks very, very suspicious, but it's just a natural phenomenon. In terms of the hexagon, I don't know, and I'm not sure if anybody knows. It's not something I have gone into in any great detail, but it's fascinating to look at. And the amazing thing is, of course, we wouldn't really have been able to observe that if we hadn't spent spacecraft out to be able to orbit over the poles. But there's so many things out there that we can't explain. There are things on Mars in terms of the geology of Mars that say that's bound to be artificial, or it's bound to indicate, for example, that there is a lake or a river there. We don't actually know yet. So, yeah, I'm fascinated by that as well. Why does Uranus spin at 90 degrees, and approximately 90 degrees, axis totally different to all the other planets? When you think of the mass of Uranus, what sort of an object or collision could take an object weighing of the order of, off the top of my head, 10 to the power 29 tons to shift its axis by, I think it's 98 degrees. There are so many mysteries out there, and that's what makes the subject so fascinating.
Yep, it goes on and on and on. It was the asteroid belt, formerly a planet that exploded. What made Russia go from, early on Russia was, like you said, ahead in the space race, but man, they really turned their attention to Venus. Yeah, and like why was that, and what did they find? And there's just so much fascinating stuff that.
Yeah, and the best information that we have about Venus came from the Russians.
Yeah.
But, yeah, is there life in the atmosphere of Venus? There was a lot of controversy about that a couple of years ago. They detected compounds in the atmosphere of Venus that they said could only be produced biologically, and then science does what it does best. A whole lot of other researchers said, no, if you do A, B, C, and the D, and under certain conditions, you can get those compounds. So they're not necessarily an indication of life.
Yeah. It's fascinating. And we get into so much on here. I mean, like ancient texts, Sumerian and Egyptian texts, when they say, "Oh, there was a time when the moon wasn't here," and just there's fascinating stuff. But
hey,
go ahead.
Sorry, I was just going to say about comets. The earliest observations of comets go actually back 3,500 years. They didn't know what they were. The Chinese called them hairy stars. They made all sorts of predictions about them. Even Halley's Comet, for example, the earliest recorded observation of it goes back to 140 BCE, and we've observed it on almost every return since. So, yeah, don't start me.
I
go on all night.
We live in an amazing universe. There's no doubt about it, man.
Yeah.
And this has been fascinating. Oh, by the way, I just found out today, too. I was looking. I guess we have a second moon orbiting the Earth.
Yep.
Through 2083, I think. And it's not
there have been a few of those. They're not strictly orbiting the Earth. They are co-orbital with it. And there are various gravitational explanations for that. Basically, they catch up with the Earth in their orbit. They get partly attracted to it, and partly the resonance effects pushes them away slightly. So they stay in our vicinity for a matter of decades, and then basically the Earth passes on, overtakes them, or they overtake the Earth. And I think this is about the third one that we have discovered. They're very, very small. But yeah, part of the fascinating stuff. It's a bit like the James Webb Space Telescope out in what's called the second Lagrangian point. It is 1,000,000 miles further out from the sun than the Earth is, so in theory it should gradually lag further and further and further beyond, but because of the intricate gravitational effects of the sun and the Earth and the other planets, it can stay relatively stable in that point.
It's fascinating. This has been awesome. I really appreciate you coming on. I hope our
Okay, pleasure, Ryan.
The one and only Terry Moseley, thank you so much.
It's been a pleasure. I enjoyed it.
What an incredible ride tonight, my friends. If you enjoyed that journey through the stars with Terry Moseley, don't stop here. Dive into the full library of episodes exploring the mysteries of creation, hidden history, and the forces shaping our world. If you enjoyed this episode, be sure to subscribe, like, and share it with your friends. We're building a strong evergreen audience here, folks, and I couldn't do it without you. Thank you so much. Want to go deeper? Become a YouTube channel member right here for early access, exclusive emojis, and behind-the-scenes content. Or join the agents of the Ryan Files on patreon.com/The Ryan Files for premium aftermath segments and bonus episodes. And don't forget theryanfiles.com is your headquarters for everything wild and weird, merch, upcoming guests, and a place to share your own story. You folks are awesome. Be amazing, be positive, and stay curious out there, my friends. And I'll see you next time right here on the Ryan Files.
Whispers in the static, secrets leave a mark. Truth ain't in the daylight, it lives after dark. Ryan's on the trail, pulling threads apart. The Ryan Files after dark, this is where it starts. Angels on the skyline, demons in the mist. Giants in the earth, fists the size of cliffs. Nephilim footprints, history's abyss. Pyramids aligned, but who's making the list? Oh God, sleeping, Yahweh's thunder roars.